Now we are going to study about the some definitions which are very important. Okay, some definitions which are important we will study now. Some important definitions related to spherical mirrors. The center of the reflective surface of a spherical mirror is called its pole. The center of the reflective surface of a spherical mirror is called its pole. And this point is denoted by the letter P in diagram. Okay, so underline this definition. Write the definition for the pole in the spherical mirror means you have to write this one only. The center point of the reflective surface. For example, this is the center point. Okay, so this is the mirror, na? So mirror surface, this center point is called as a pole. Okay, spherical mirror. If the mirror is like this, if the spherical mirror means the dotted line, hollow glass sphere. This is a spherical mirror. So if it is showing this inside, na, so maybe this is the which mirror, concave or convex mirror. Which mirror it is? It is the concave. Okay, it is the right beside concave mirror. So how the concave mirror works? Some rules, laws and regulations we will study. The center point of the hollow sphere, okay, spherical mirror glass is called as a pole. It is denoted by the capital letter P. And the next definition is, as you know, a spherical mirror is a polished part of a hollow sphere. Therefore, the center of the hollow sphere is called the center of the curvature of the mirror and is denoted by C in the diagram. Okay, the center point of this hollow sphere glass is called as a center curvature. It is denoted by capital C. Underline this definition also. Another one, and C is not a part of the surface of a sphere. It lies outside the surface. The distance between the C and P, which is also radius of the hollow sphere, is called the radius of curvature. It is denoted by capital R. And this pole is at the center of the surface, but this C is center of curvature is outside the surface. Okay, this is the surface of the mirror, but it's outside the surface of the mirror, na? Yes. The distance between the center of the curvature and pole is called as a radius of curvature. Radius of curvature. It is denoted by capital R. Okay. And the next definition. Okay, another one. The line passing through the center of curvature and pole is called the principal axis. Okay, it is perpendicular to the pole because any line through center of a circle is perpendicular to the circumference. The diagram represents the cross section of a spherical lens, which is a circle. That means it is a half one cross piece which is denoted by the circle. Okay, and the line passing through the center of curvature and pole is called as a principal axis, and this line is perpendicular to this plane surface. Okay, perpendicular to the surface of the spherical mirror. So it is the principal axis. So at the same time, like that only for the it is in which mirror? This one is the convex. Okay, convex mirror, bulging outside. Now outside we can see, and if lines will show, this side is polished, big back side of the mirror. These lines will show back side of the mirror. So mirror is this side. So it is the convex. It is the convex mirror. Okay. So like that only the center of the surface of the spherical mirror is called as a pole. At the center point of the spherical mirror is called center of curvature. It is denoted by capital C. The line passing through the pole and the center of curvature is called as a principal axis, and it is perpendicular to the surface of the mirror or pole. Okay, it is this one. And another important point we are going to study about the focus. Okay, so for this there is a one activity. Through activity we will see what is the focal point. Understand? So And one more thing, okay, now take a concave mirror and place it so that the reflecting surface is facing towards the sun. The light coming from sun gets reflected from the mirror. We will try to obtain the reflected light on a piece of paper. Okay, place a paper in front of a mirror and adjust its position till a very sharp bright point is seen. This is the image of sun forward from the mirror and obtained on the paper. Okay, which acts as a screen to obtain image. Okay, here we are taking the concave mirror. In front of the concave mirror, we keep one white paper and we concentrate on the sun. The sun should fall on the paper. Okay, so here is the mirror is here. This is the mirror, concave mirror na, and paper is here. This is the paper and here is the sun. Sun light is falling here, reflecting. This sun image is falling where? On this paper. Sun image is falling on this paper. Now this paper is the screen for this mirror. Okay, sun is there, so sunlight is falling on the mirror. So the image is not falling inside of this mirror. When we see our face in the mirror, our face we can see inside the mirror na, that means back side of the river, inside the mirror. But here the image of the sun not seen there, but it is falling on the paper. Now this is the screen for this mirror. Okay, so the image of the sun formed has been obtained on a, obtained means mila, got it on a screen outside the mirror, not inside the mirror. So it is a real image. Okay, so last one assignment you have written the properties of the real image and virtual image na, the differences between the real image and virtual image. So real image means which falls on the screen. It does not fall on the inside the mirror, it falls outside the mirror. Okay, where the image is forming, it is the on the screen it is falling. So it is called as a real image. Okay, underline this point. Obtained on a screen, so it is a real image. The point at which the image is obtained is called the focal point of the mirror. As you can see, the focal point lies outside the mirror. The focal point indicated in the diagrams by the letter F. So here is the mirror, here is the paper. Okay, and this is what? Concave mirror, and sun image is falling on this. So it is falls outside the mirror. Where this sun image is falling, that point is called as a focal point. Okay, so here when we see, this is the concave mirror, this lines will show always back side of the river. So in this concave mirror, where the light is falling, where the image is forming, it is called as a focal point. Okay, so in case of a concave mirror, light rays coming parallel to principal axis. Parallel to means you know na, so line side by side facing each other, this is called as a parallel. If the line is like this means this is perpendicular to this. Okay, perpendicular, and like this means it is the parallel. Okay, so light rays coming parallel to principal axis, this is the principal axis, the middle line, principal axis. So the light rays falling on the mirror, all these are the parallel to the principal axis. Okay, so here in case of convex mirror, rays coming parallel to principal axis appear to be coming from a focal point. The image formed in case of a convex mirror cannot be obtained on screen. It is called as a virtual image. Here two differences you see. Real image in a concave mirror, it falls outside the mirror where on the screen, so it is a real image. But when we see in the convex mirror, this is the convex mirror, so lines will show outside. Convex mirror means image is forming where inside the mirror, image is forming inside the mirror, so it is called as a virtual image. If the image forms behind the mirror is called as a virtual image. Okay, so is called image formed in case of a convex mirror cannot be obtained on a screen. It will not obtain on screen but behind the mirror. It is called as a virtual image. So here focal point is this one, here image is forming. So this rays it will be appearing, it will show dotted lines are not real lines, but dotted lines will show as though light is coming from the focal point. Light is coming from the inside of the mirror, it will show. So appear, as it appear to be, appear means seeing, it will show as though it is coming from the inside, which is wrong. Okay, dotted lines will show. So here the rays are parallel to the principal axis, but rays will show as though it is coming from there. Okay, so where all the rays meet, at that point only image will be forming. So here all the rays are meeting at this point, understand? So it will be reflecting back again, and this will be reflecting back again, all the rays will be meeting at one point. Reflection, so light is falling, it is the incident ray, and it is reflecting back, it is the angle R. So this middle line will be the normal ray. Okay, so this is the one.